on wireless sensor network, practice and design in industrial standard on this video. My name is Prince Lamathing and my student code is 322672115. Introduction. Industrial wireless sensor network brings various advantages over traditional wired industrial monitoring and controlling systems. That includes self-maintaining, flexibility, faster deployment, smart processing capability. The concept of smart industry wouldn't have existed if the sensor technology wouldn't have been adapted in industry standard. And the sole purpose of development of sensor technology is to enhance the industrial process, reducing the most of the human use and increasing the product. Here are some goals of IWSN, which I will be discussing further in the coming up slides. But before that, let's talk about some challenges. Resource constraints, energy memory, processing, dynamic topologies and harsh environment conditions, quality of service requirement, data redundancy, packet errors, and variable link capacity, security, large-scale deployment, and ad hoc architecture. Long life assurance, low cost, and the size of sensor nodes are very important while designing the IWSN. Lifetime of sensor nodes has much importance in IWSN, especially in automation and process control application. Energy harvesting techniques must be considered to offer an extended lifetime of IWSN nodes. In comparison to that of the industrial machine, a detailed discussion on various energy harvesting schemes, cost and size of the production of the nodes, the capacity of the batteries and supercapacitor is in need. The practical evaluation of these schemes in industry environment can lead to more accurate time and capacity information of the various plants. Efficient information scheduling is also very important while designing the IWSN. The information scheduling plays a significant role in heterogeneous industrial network. In a system with a different process integrated, the sense data originated from various sources may have various time deadlines, sampling rates, priority levels, and failure consequences. However, there is much more potential for improvement where the active schedules of information can resolve many fundamental problems of synchronization, sleep scheduling, contention-free medium access, coexistence, reliability, and interference. Thus, where a good schedule design is a principle of the importance in TDMA based industrial communication standard. A poor schedule may lead to a violation of time constraint in harsh industrial environments. Data fusion and localized processing. Data fusion is an essential aspect of IWSN and can be hugely beneficial in harsh industrial application. Localized processing with the efficient data fusion can significantly help in transforming large data into a compressed critical information. Localized processing also reduces the time delays between the reading sensor value to control the actuators. In efficient implemented, this process can help in eliminating some severe constraint in IWSN, including data redundancy, time constraint, and network lifetime. Variable sampling rates and heterogeneous sensing. The information generated in a plant is usually critical nature, but its significance rises even more when it violates the violet thresholds. In such instance, it is imperative to observe the status of information more frequently. The design cannot rely on static sampling rates. Instead, it must adapt to the changing static of the data from different sections of the plant. Hence, the incorporation of the variable sampling based on the critical nature of the knowledge is imperative for a better technical solution. Loads and to trade off between the frequently desired and less regularly desired information can significantly improve the reliability of the network communication by effectively managing the bandwidth fluctuation and resource constraints. However, to establish a difference between the different Sensing is used in sense of quantization information and the number of bits assigned to the sense data. As in IWSN, it is a paramount importance that the data from the different sources according to the nature of knowledge, not only in the sensing of the priority but also regarding the sampling rates and affordable quantization error of the sense information. Therefore, the heterogeneous sensing, though rarely used, can make a significant difference in reducing a load of stress network downscale. The number of bits used to represent an analog sensor value, the decision on when to cut the precision of the sense information is a question. How significant and detected data is, and will it affect the process outcome to get the desired result? Thus, the merging different signals and allocation of non-uniform resource must primarily be considered in design. Dynamic priorities, scheduling. Industrial processes are not limited to one specific task or industrial system. For example, an industrial process can be communicating emergency traffic, regulatory control traffic, alerting traffic, and monitoring traffic. In such method, the multi-level prioritized communication offers a better chance of effective communication optimization. However, the trend is use of predefined priorities for even industrial traffic type. The response of the communication protocol only to predefined states and hence is suitable to handle the dynamic process. The priority of the traffic in industrial network can change on runtime. Depending on the sensor reading, the use of the predefined traffic priority may be a suitable solution. Hence, the priority-based MAC protocol for the IWSN are inefficient in scenarios where specific variation in the current preference can occur. The example of such cases, including the alert system, where the violation is critical approach in runtime may result in instability in the plant's operation. Under such circumstances, the alert system traffic priority increased due to its recent critical nature. Similarly, the real-time variation is supervisory control feedback also changes the priority of the affiliated traffic, and more regular feedback is preferred. Therefore, a more effective way to deal with a process like these is by establishing the dynamic priority, which could prioritize in real time. The concept behind the dynamic priority scheduling is to form an adaptive and evidence based decision of which information is more critical and must meet on priority. The inclusion of dynamic priority scheduling meets the challenge of the time constraint and the information priority scheduling by efficient sacrificing the bandwidth of the low priority data sources. Data reliability, time synchronization, and retransmission scheduling. Reliable data communication has significant in IWSN, and accuracy of each transmission is paramount. It is for the same reason retransmission is very important to achieve the desired level of quality of service. In the aspect of 802.15.4e can serve as an excellent example as it offers the interference-free channel access. It also implements the time synchronized channel hopping TSCH for better reliability. However, the desired packet reception rate PRR could be challenging due to some significant interference resources native to the industrial environment, ensuring a quality of service. Also, certain communication types in IWSN, the retransmission is scheduled. The shared slot provided in 802.15.4 standard for this purpose, but the default retransmission uses CSMA/CA based channel access during the shared slot, which makes the reliability and the timely delivery of the already delayed information questionable. In this aspect, the minimal research is available to improve the retransmission efficiency in TDMA-based multi-hop IWSN using the efficiently scheduling the shared slot in a priority mechanism defines which attempts to To improve the retransmitter efficiency in TDMA-based multi-hub IWSN using efficiently scheduling the shared slot in priority mechanism defines which attempts to improve the quality of service. High priority communication by allowing it to retransmit the failed communication of high significance over the time slot assigned to lower priority communication, hence offering better reliability. Further improvements are also expected in this domain. However, it requires more investigation and research for the optimized solutions. As you can see, there are the different levels of reliability checks, packet level and event level. So based on the type of disaster or type of retransmission required, or the reliability check, or the time synchronization check, the packets are transferred. Application specific secure and resource efficient design. Careful observation of the parameters in plant can give an insight into the suitable solution for the selected application. A prime answer in the field of IWSN that can perfectly fit every application is a myth. Therefore, one can not deny the need for the application specific design in IWSN. Apart from this, if the wireless nodes are used to develop a generalized solution which can work in a wide variety of applications, it might need a lot of resources. For instance, Zigbee, wireless HART, and all those. The maintenance, modification, deployment, packaging services, and unit costs, the solution becomes unfeasible. Therefore, most of the application tends to offer compatibility with a single communication protocol where few nodes can also work as a gateway to interconnect with other technology. An application-specific design offers more promising of fulfilling the desired object with the minimum resources and the lowest cost possible. With all the primary goals covered, one may look further to optimize the efficiency of the design by incorporating the transmission, power control, sleep scheduling, and energy harvesting for the network lifetime improvement, distributed processing, linearization, useful memory mapping, and code optimization for the efficient resources, design and modular approach, clustering, and hierarchical design for the scalable solution. However, to propose a solution suitable for the application as well as to offer the possible potential for the future development in challenging tasks. Apart from this, an industrial answer based as WSN is expected to be efficient and scalable. The IWSN not only have to adjust with the existing field bus, the Ethernet legacy solution, but also must deal with the changing and ever expanding industrial structure. In such case, for the scalable architecture, the modular approach and the hierarchy based solution is preferred. Furthermore, it is recommended for the efficiently utilize the resource from the implementing efficient memory allocation algorithm to be sophisticated techniques to prolong the network lifetime and the secure network. Industrial application. Network of the wired sensor have long been used in industry fields such as industrial sensing and the control application, building automation and the access control. However, the cost associated with the deployment of the wired sensor limits the applicability of this system. Managing inventory, monitoring product quality, constructing smart office space, environmental control of the office building, robot control and guidance in automatic manufacturing environments, factory process control and automation, monitoring disaster areas, smart structure with the embedded sensor nodes, machine diagnosis, transportation, factory instrumentation, local control of the actuators, vehicle tracking and detection, instrumentation of semiconductors, processing chamber, rotating machinery, wind tunnels, and distributed spectrum sensing to help realize the cognitive radio networks. Sensor technology can also be act as a simulators training. For example, let's say a BHP is organizing a field trip in a simulation for the workers and the miner training. So what they can do is like they can create a picture of the mine sites based on the sensors and can locate each and every workers inside the mines, and they can even teach and enhance through VR technology. They can see where the miners are, and all this kind of stuff. This is a picture of how the sensors would work in a commercial use, but this can also be used in industry standard. It there's readers, stop bar detection, access point, traffic controller, and there will be enhanced detections, which will be all the messages will be sent to a server, and then all the information can be calculated. Widely used standard in IWSN. Zigbee, a mesh networking standard based on IEEE E 802.15.4 radio technology targeted at the industrial control and monitoring, building and home automation, embedded sensing, and energy system automation. Wireless HART, it's an extension of HART protocol and is specifically designed for the process monitoring and control. The technology employs 802.4.4 based radio frequency hopping redundant data paths and retry the mechanism. For example, smart wireless network using wireless hub product can automate the temperature and flow monitoring to increase the production of the company's offshore platform. Needing a monitoring approach able to be installed without the interrupting flow, operators are using wireless device to transmit real-time data that monitors the temperature and flow. The developed WSN is allowing quick reaction to any loss of well pressure and maximizing the throughput from the well. UWB ultra-wideband is a short-range wireless technology based on the transmission of very short impulses emitted in periodic sequences. 6LoWPAN aims to standard IP communication over low-power wireless 802.15.4 network standard utilizing the IPv6. ISA 100. The ISA 100 working group is focused on reliable wireless communication system for monitoring and controlling applications. So in conclusion, therefore, there are many features of wireless sensor network designed in industrial standard revolutionized and automated the industrial process, making it simpler and easier to manifest the product. Hence, the mentioned points on this slide needs to be considered during the deployment of the sensors in industrial standard. Thank you, Dave. If there are any questions, please send me a